I've got two questions here, which is you have direct experience at a major transmission and distribution company. I'm not going to name their name, but um, how how insightful are they on this topic of reinforcement learning? Because this would seem like a very amazing tool for someone that owns transmission and distribution assets.
Can I add one more thing to that? Before they get to the reinforcement learning or deploying the reinforcement learning agent, how long do they have to do supervised learning or unsupervised? Do they even do unsupervised learning in the context of a power utility company?
It's a great question. So I would say that often, you would use supervised to unsupervised to reinforcement learning. It's not that it's exactly a progression. They're paradigms that solve different problems. Mm-hmm. So if you want to do something like predict how much solar power output you're going to get from your solar panel based on the weather and mm-hmm. Time of day and all of that, then that's pretty, nicely framed as a supervised learning problem where you have some information about your historical weather, historical inputs, and then your solar power output, and you can just map between them. Yeah. But then the question is, if I have a prediction, what do I do with it? What action do I take? Sure. And that is not something that, supervised learning or unsupervised learning canonically would solve. That is just canonically a reinforcement learning problem where you're trying to learn some kind of action. Yeah. So these algorithms
do you bring on the peaker plant or not? I mean, that's
exactly. Yeah. And these algorithms do kind of, interplay with each other. But they don't have to. In some sense, I could produce a manual prediction of solar power output, and that would still be a reasonable input to my reinforcement learning algorithm in order to do something automated. So yeah, they solve slightly different problems. And John, to your question about, the readiness, I guess, of different system operators, I would say that because these things solve different problems and because the input technologies or just the situation around the availability of data and simulators is very different for these, I would say that many power system operators actually very widely use machine learning for what I would call situational awareness problems. So I want to know what my solar power output will look like. I want to know what the state of my system looks like, because I want to lead somebody to be able to take an action in a way that the system operator views as being trustworthy based on that information. Whereas reinforcement learning is very much about having the machine learning algorithm itself take some kind of action. And there's, understandably more hesitance around that because you really can break your power grid if you do something wrong. And so one kind of publicly available challenge is actually by RTE France. They run a public challenge called Learning to Run a Power Network, or L2RPN. They've actually created some basic simulation environments that try to reflect some of the realities that the French system operator is seeing on their power grid, and basically kind of present that as a challenge to the machine learning community to say, can you come up with a reinforcement learning agent that either, automatically or in some of their challenges in a human in the loop way is able to come up with good actions that we can actually take on our grid.
At 80% nuclear, it's an easier problem to solve.
Got to start somewhere.
Totally agree. But this reminds me also, this simulation requirement, like these environments, it reminds me a lot of the late 90s where, mobile phones were just kind of becoming very, very, very popular at the time. And everyone was trying to do apps on these mobile phones. But of course, the mobile phone companies and the carriers didn't want you to play with live ammunition. They didn't want you on the real devices right out of the gate. Now, very different problem if your phone crashes than if the power grid crashes. So I can understand the level of safety and reliability is very, very different. But it seems like there's a place in this new world for power simulation environments where people can test their tools safely, and it can raise awareness and trust of these transmission and distribution owners. So there's a whole business probably in just making simulation elements or environments. Is that right?
Yeah, absolutely. And I think that the challenge is, I think there's a lot of utility and value, utility in the sense of usefulness as opposed to power utilities. There's a lot of value in making these kinds of simulation environments available. But it's the classic problem that comes when you look at the startup landscape. Everybody wants to build the things that create profit and value on top of infrastructure that already exists. Often you have some kind of, public goods issue when it comes to actually building the infrastructure that everybody can build off of. And so I think clever business models can help with this, but I also think that this is a place where public funding and public-private partnerships can really play a huge role in kickstarting this.
So Department of Energy, EPRI, universities, these kind of places are the place to incubate these kind of environments to test this stuff. You think that's the best place?
Yeah. Okay. And I think, again, in collaboration with startups and others who would be the users on the other side, I think you don't know if a system is useful until you actually try to use it. And I think knowing that sooner rather than later, even in the early stages of development of these kinds of systems, is incredibly important.
Fantastic.
Yeah.